We restored 5 volts. We fixed 1.8 volts. We fixed packs. We fixed the PCIe 12 volts, the short. We fixed the broken trace. And we still have 6 beeps. The card is still not working. It's personal now. We're gonna continue working on the MSI Ventus 3090 that we worked on yesterday. It was end of the day, and I had to leave it until today. To refresh your memory, the card was mailed in for no power. That's how the card looks like. And the first thing I did was I measured for a 12 volt short. We did not have any short on the 12 volt lines. I went a bit down to the 5 volt rail. I measured and we had a short circuit. I also did a quick visual inspection on the board and discovered that we had a short circuit, a blown inductor all the way right here. I already removed the inductor. If you have not watched part 1, I'll leave a link down below so you can watch it. A lot of things to learn. What we did was I measured here and we had a 5 volt short. From experience, I went over to this chip. I measured in diode mode the 12 volt line. We did not have a short. I measured 5V, and of course we had a short on this pin. We should not have a short. Pin number 4 is ground. Pin number 5, we had a short circuit, P good. Pin number 6 is enable, we did not have a short. Pin number 7, VCC, we had a short. And feedback, we did not have a short. So overall, we had shorts on 3 or 4 pins. Usually the only short we should have on this chip is pin number 4. So what I did was I replaced the chip and the short was gone. Now if we measure the 5 volt line, let's do it together. We're gonna go to diode mode and we're gonna measure here. And now we do not have a short anymore. Before we had a short. If we measure 12V, like yesterday, we did not have a short. If we measure 5V, we do not have a short. Ground, we have a short. P good, we do not have a short. Enable, VCC, and feedback. Perfect. The only ground we have on the chip is pin number 4. Now I did a visual inspection on the board and I realized that we had a burnt inductor or a blown inductor right here. I removed the inductor and of course we have a short right here still. No short here. We are reading 2.2 voltage drop and we have a short here. Now a short here is likely a problem with one of the DR MOSFETs that we have on this side of the board, right behind that inductor. We're gonna go over the thermal camera again. The battery went out on the thermal camera yesterday, and that's one of the reasons I had to leave this repair until today. Battery is charged, and we're gonna inspect this area under a thermal camera again while injecting voltage. It's very likely a shorted DR MOSFET that we need to replace, and we should be back in business. Okay, and I see it right there, right at where the X is, the target. So which one is this? If we count from the bottom, ASUS, it doesn't power on?
It doesn't power on.
Okay, let me see.
I tried. So I went to like an ASUS repair center.
Okay, so for this model, it's $395.
Okay, sounds good.
Okay. Now, if we work on it, we're gonna take it apart. We're gonna work on the motherboard. In case we were not able to fix it, then you will still owe us $125 for the bench fee.
Yes.
$125 is due now, and if it's a fix, the $125 will apply towards the final amount.
Okay.
Okay. If you check your Gmail, you should already have an email from us with your ticket number and everything. And once we are done with the laptop, we update the system and it sends you another email to let you know that it's ready for pickup.
Got it.
All right, so based on the thermal camera, I'm pointing my tweezer over the component that got hot, over the DR MOSFET that got hot, and it's right here. Which one is this? 1, 2, 3, 4, 5. That's the bad guy, right here. One thing I want to do to desolder this DR MOSFET is remove this cap, this one, and this one. I do not want to take any chances. I can block them like I usually do, like I've done with so many videos. But I do not want to take the risk where one of the caps will pop. So I'm going to remove 1, 2, 3. I'll safely remove and replace this DR MOSFET. Then I can put those caps back. 2 or 3 of the videos I've done, those caps, one of them popped. And when it pops, it flies like a rocket, randomly. We're going to use low melt solder. Fume extractor on. So the first cap is out, and that's the magic of low melt solder. I mention it in every video. Low melt solder is magic. We still have some low melt solder left on the tip. Let's do this one. And cap number 2 is out. Let's add more low melt solder. Oh, bummer. I did not realize I switched to the wrong channel. I had the blue screen on. Not a big deal. I did desolder the DR MOSFET after removing the 3 caps and cleaning the 3 caps. I do not know how much I missed, but I removed the 3 capacitors, cleaned the holes. Then I pointed it here, removed the DR MOSFET, and that's where we are right now. And now we have to put the capacitors back. All right, so all 3 caps are back in place. DR MOSFET replaced, and all we have to do is replace the inductor. And we'll test again. Look at the quality of the joints when you have good flux and good soldering wire. All the tools that we use on our bench can be purchased off our site. Just log into NorthridgeFix.com, click on shop, add to cart, checkout, pay, and we almost always ship out same day. We carry everything from this amazing microscope, articulating arm, flux, braid wick, soldering stations, hot air station, thermal camera, whatever you need, one-stop shop. And we are done. Just a quick cleanup, and we'll test the car together. Hopefully it's a fix. So a lot of things, right? DR MOSFET, 3 caps, we put them back. We replaced a chip right here, right next to the inductor. We replaced the inductor on the back. Let's quickly measure in diode mode. Make sure we do not have a short anywhere. Time to plug the cord in. Okay, so we have the PCIe adapter which connects to our Dell motherboard. We have two power inputs, 12 volts and 12 volts. HDMI cable. And right now we have two options. Either we're gonna get an image on the screen or we're gonna get 6 beeps, and that's not good. Image is good, 6 beeps, not good. And for the time being, I'm gonna put this heatsink right here. And goggles on. I do not want anything blowing in my face. What if? Power supply is on. And 6 beeps. What's going on? We're gonna have to measure. Do we have 5 volts? Meter in voltage mode. And I'm gonna measure at the inductor, at the 5 volt inductor, and we have 0 volts. Maybe we have a blown 0 ohm resistor somewhere. Yeah, we have 0 volts on the 5 volt rail. If we do not have 5 volts, we're not gonna have 1.8 volts, no core, and video card will not work. If we measure here in voltage mode, we should have 12, and we do. 5 volts we're not gonna have. It should be 5, but we have 0. Ground on the bottom, we do not care about. P good, do we have it? We have 0. What about enable? Enable, we have 0. VCC we have 0. So everything is zeros. What's going on? We do have 12 volts, so we know that the card is getting power. We're gonna have to figure it out. I do not have any board view diagrams for this card, and now I do see an exposed line here. Let's go ahead and replace this chip and see what happens. One more time. Power on. And no power. We still have 6 beeps. Wait, no, yeah. Custom adjustment. Okay, so I spent like 10 minutes going over the card. And after a lot of investigation, here's what I found out. Now, if you look at this exposed line, I measured right here with the card plugged in and powered on, we have 12.26 volts. I measured here, we have 12.26 volts. I measured here and we have 0.016 volt. Can you believe it? Can you believe this? Wow. We have a break in the line. So here we have 12.26 volts and here we have nothing. So 12 volts is not reaching its destination. Let me turn the power supply off and we're gonna restore that line. I mean, who would have thought that the problem is coming from this line? The line looks good. And here we have it. The line is broken. So we're gonna measure again. Meter in diode mode. And do we have a continuous path from here? To here? And we do. We do. We do. Are we gonna get a working card? Are we gonna hear 6 beeps? And we still have 6 beeps. We still have 6 beeps. Unbelievable. How many issues do we have with this card? So while the card is still plugged in, let's do some measurements quick. How many issues did we fix with this card so far? Unbelievable. If I did not see light at the end of the tunnel, I would not continue with this card. But I know I'm almost there. If we measure here in voltage mode. Oh, look at this. We have 5 volts. We have 5 volts. Okay. Look at this. Look at this. We have 5 volts now. But the card's still not working. Let me measure rest of the voltages. Let's go to 1.8. Do we have 1.8 volts? And we do not have 1.8. Let me turn the power supply off. I'm gonna turn that back on. And we do not have 1.8 volts. Let me measure 1.8 in ohms mode. And we have 224 ohms, which is good. Let me measure packs quick. We should be between 4 to 9 ohms. And we have 7 ohm. That's good. So why we do not have 1.8 volts? That's a very good question. Let me flip the board in exactly the same area, and we should have a chip labeled ALNB right there. And let's go ahead and replace this chip. Let me see if we have another one. And it looks like I used it from this donor board. What about this one? And I used it from this donor board as well. What does that tell you? And I replaced it from this donor board as well. And now that we need this chip, I'm not gonna find it on any donor board. I do not have it in stock, so I need to look for one. Do we have one here? Just a minute. I need to look for more donor boards so we can grab that chip. I have like 15 donor boards right next to me, and not a single one has that chip on the board. I used all of them. All right, so I got this donor board here. Hopefully we have a chip on this board. ALNB, right there. Let's start by removing the chip from the donor so we can put it on the side. Are we gonna have any more issues? Will this fix our missing 1.8 volts? One way to find out. Now we're gonna realize that we do not have memory. What's next? I'm done with this card if it does not work. Heatsink. Just a small one for now. And are we gonna have a working card? Let me measure 1.8. Do we have 1.8 now? I'm running out of patience. And we do have 1.8 volts now, so we did fix 1.8 as well. We restored the 5 volt line. We restored 1.8 volts. Let me measure the rest of the board quick. We have 1.8 volts now. If we have 1.8 volts, it means we have 5. That means we have 12, so we do not need to go and measure those. But I'm gonna turn off the power supply. Back on, and we're gonna quickly measure packs. And we are missing packs. We are missing packs. So we have to measure it immediately after we power the card on. And we have no packs. 0. 0 volts. Let's do the same thing for packs. Power supply off. We're gonna do the same thing to PAX like we did with 1.8 volts. That short on the board killed a lot of things. We're gonna replace this ALNB chip. You should be able to use this video as a one-stop shop to know how to troubleshoot any issue with a video card. Because every issue known to the human race fixing video cards is in this card. Shorted 12 volts, PCIe, we had to replace a DR MOSFET. Shorted 5 volts, missing 1.8 volts. Broken 12 volt trace. What more do you want? All right, so what do you think? Will the card work? And we have 0.4 volts on PAX now. Before we had 0, now we have 0.4, and that's not good. It's still at 0.4, 0.41, 0.4. We did not lose PAX yet. Look at this. That's PAX. 0.4. We should have 0.9 and not 0.4. So we did something positive, but of course we have more issues. Unless the chip I replaced is not good. Unless that chip I replaced is not good to begin with. Is that possible? What time is it right now? I need to do the 4090 and $328. Let me put this video on hold. I'm gonna do the 4090 connector. Big Boss is waiting for me so he can reassemble it, and I'll continue with this video. And I just want to show you what's going on with this 4090. It came in for a connector replacement, and I did not know that the person who mailed it attempted to do it himself. Look at this mess. Look at this mess. Did he already replace it, or we still have the old connector here? We still have the old connector. So he attempted to remove the connector and was not successful. He did not realize that this is a 12 to 15 layer board. It takes an extreme amount of heat to desolder this connector. It's not a DIY job. Let me do this, finish it, and I'll be back. And the job is done on the 4090. I just wanted to show it to you. If we check back of the board, solder made its way all the way through the pins to the top. I'm gonna hand it over to Big Boss to reassemble and test, and we're gonna continue working on the MSI 3090. I ran out of flux. I'll be back. No problem, because we have a flux factory here in the warehouse. A new syringe, original Inventec Amtech Flux. We are a distributor of the flux, and almost every repair shop, every hobbyist, they buy their flux from us. You cannot buy original Inventec Amtech Flux off eBay, not off Amazon, not off AliExpress. You can buy it from NorthridgeFix. Very nice, the chip is soldered on nicely. Power supply is on. And we still have 6 beeps. Let me check PEX quick. What voltage do we have on PEX? Right now PEX is reading 0. Let me turn the power supply off and turn it back on. We got PEX. We got PEX. But we still have 6 beeps. We got 5 volts, we still had 6 beeps. We got back 1.8 volts, we still have 6 beeps. We got PEX, and we still have 6 beeps. Look at this. 0.9. I never seen a card relentless like this with so many issues. We restored 5 volts, we fixed 1.8 volts, we fixed PEX, we fixed the PCIe 12 volts, the short, we fixed the broken trace, and we still have 6 beeps. The card is still not working. It's personal now. Let me measure memory quick. Do we have core? Let me check if we have core. And we do not have core. Let me turn the power supply off and back on again. And we do not have core. Core is 0. Power supply off. Back on. How about memory? And memory is 0. Memory is 0 as well. Core and memory are 0. Right now, I did everything that I could. The problem, as I see it, may be core/memory related. I'm glad I have everything on video. It's a very good video to learn from, fixing all sorts of issues on a video card, but I'm gonna have to call it quits. If you have any suggestions, any comments, any hints, you can always leave it down in the comments, but we're gonna end the video right here. I hope you enjoyed it. Don't forget to like and subscribe, and we'll do something else in the next video. No fix. What can you do?